Good morning, afternoon, evening. Welcome to this session on the standardization roadmap to 6G. My name is Alain Mourad, and I'm the moderator of this session. I am a director engineering at InterDigital in the United Kingdom. With me today, I have a stellar panel composed of Giovanni Romano, a standardization lead at Telecom Italia, Joseph Levy, a principal engineer at InterDigital, Diego Lopez, a senior technology expert at Telefonica, David Boswarthick, Director New Technologies at ETSI, and Raymond Knopp, Professor at Eurecom and the President of Open Software Alliance. I will kick off the session in the next couple of minutes and will then give the floor to each of the speakers to present within 10 minutes his perspectives on the topic. We will then follow with a half-an-hour questions and answers discussion at the end. So where are we today? Earlier this year, the ITR issued its recommendations for the IMT 2020 system, consisting primarily of the 3GPP 5G submission. In parallel, the 3GPP has continued to advance 5G with its current release 17 and upcoming release 18 in a backward-compatible way. These advancements have been targeting at a progressive extension of the services supported, a moderate increase in performances, and a move to specify 5G evolution in the remainder of the IMT 2020 spectrum from 50 GHz up to 100 GHz. At the same time, the ITR has already started an effort to lay out the vision for IMT 2030 and capturing future technology trends. This is envisioned that in the next couple of years, around 2025, we will reach an inflection point where current backwards compatible advancements of 5G will not be enough to address the new services and performance needs and support the new technology trends. This is when 6G specification is envisioned to begin, mainly targeting at the support of new services with extreme requirements, a drastic increase in the performance compared to 5G, and a move to specify solutions beyond the current IMT 2020 cap of 100 GHz. The 6G standards will power new 6G products and services until 2045-2050. With this roadmap laid out, all the key 6G standardization stakeholders are already incubating and planning for 6G in parallel, with apparently a shared desire for 6G to be data-driven, automated, and intelligent. On the vision and requirements front, several forums are being active, like NGMN, 5G Asia, TMF, and ITR IMT 2030. On the research and innovation front, several research programs have already launched or are launching to explore the 6G technology landscape. Examples of these programs include Horizon Europe, Smart Networks and Services, the UK Research and Innovation, USA NSF and Next Generation Alliance, China, Japan, and Korea 6G Fora, and many others. In the standard organizations such as ETSI, IETF, IEEE, ITUT, and 3GPP, various pre-standard studies are already being incubated to pave the way to 6G. With this, we will next hear from the speakers on various aspects impacting the 6G standardization roadmap. First, we'll hear from Giovanni on the road to 6G from vision to research to standardization. He will then be followed by Joseph, who will address the role IEEE is playing and will be playing in delivering 6G. Diego next will address a question of how new times require new ways to build standards. Next, David will present the long-term roadmap of ETSI for supporting the delivery of 6G. And finally, Raymond will address the role of universities and open source communities in accelerating 6G innovation. With this, I'll hand the floor over to you, Giovanni. Please take it away.
So what I would like to introduce is, let's say, a parallel to see if we can draw a parallel between what happened with 5G and what will happen with 6G. So if we go to the next slide, we can see a chart which is very similar to what Alain just showed us a few seconds ago. So we had in 5G different actors working on the stuff. So pre-standards, doing lobby, doing requirement, doing providing ideas. Then the standardization, which was focused for at least for 5G mainly on 3GPP, ITU, but also with the help of all the relevant fora which provided the full system component. And then we had the policy profiling, so the spectrum, but also, for example, GSMA, which provided for voice over NR, the profiling, and all this kind of stuff. So a lot of activities. But 5G also saw new players enter the game, the so-called verticals. So 5G SCAA, 5G AA for automotive, ISOA for satellite, and so on, just to cite some of them. And I think that the key point in 6G is that this player will be there since the beginning. Maybe in 5G they started entering the playground a little late when they saw the opportunity that 5G was given to their industry. 6G, they will be there since the beginning. But there are also other players. For example, in NGMN, we are contacting let's say, not technical association, for example, to see if there is any requirement from society, from example, the United Nations, to see what we can provide to provide connectivity to everybody. The emergency we are living every day is something that showed the importance of connectivity, not only in the big cities but everywhere. So that is the point I would like to stress, that the new players that were there in 5G will be there since the beginning. The new player maybe will be the society and other associations which are not technical, but are providing a requirement from and to the society. Next slide, please. So, okay, this picture maybe is a little confusing, but I just wanted to draw really a parallel between what happened in ITUR with IMT 2020, so with 5G, and doing some kind of a reverse engineering, what we could expect for 6G, at least from ITUR perspective. So what is called the IMT evolution beyond 2030, and so on. I think there is not yet a public name, but we all expect to be IMT 2030 or something like that. I think that Alain indicated something like that in his slides. So if we look to the evolution, then the deadline for the publication of the recommendation from ITUR is 2030, like it was 2020 for 5G. We can expect that in 2029 we will have the self-evaluation and the acceptance of the proposal to be included in 6G specifications. But if we go a few steps back and draw the complete parallel, we should expect ITUR and ITU to start working on 6G around 2024. What I would like to stress in this slide is that actually ITUR already started working on the technology trends on the future technology trends and the work started in 2021. So are we seeing a sharp acceleration, also a lot of activities on 6G and so on, so which is driving the standardization, or what will happen? This is just an open question to everybody. Next slide, please. Okay, this is again a reverse engineering from 3GPP perspective. So again, if we look to the ITU, our timeframe for 5G, we should, and we looked what was done from 3GPP perspective, we saw that the end, let's say, the recommendation on IMT 2020 was finalized by ITUR in November 2020. And 3GPP had to provide the final contribution in June 2020. Similar way, 3GPP provided the input on release 15, complete release 15 in June 2018, and so on. And especially if we look to the starting phase, the 5G requirements were specified in release 14 so in October 2016. And the 5G study was also finalized in release 14 in beginning of 2017. If we draw again a reverse engineering exercise, we can expect that, let's say, around June 2030, there will be the GPP final submission to ITUR. If we follow exactly the same process, so we can expect that. Take into account that the GPP releases are usually 15, 18 months long. That could be release 22. Then again, some backward engineering, the basic 6G could be release 21 in somewhere in 2028. And finally, but not less important, the requirement and the study should be in between 2024 and 2026. Again, don't keep, those are not official dates. It's just an exercise of reverse engineering to see what happened in the past and see if we can draw the parallel in the future. Next slide, please. Okay, as I was saying, now it's the time for creating the ecosystem, so to influence the ecosystem. As for in 5G, NGMN provided a quite important white paper, which was providing the view of the mobile operators and the, let's say, mobile ecosystem. That paper was published in February 2015. And now NGMN just published the first input from the mobile network operators perspective on 6G drivers and vision. So the paper was published the beginning of April, so it's very fresh. You can find the web link in the slide. And the important point is that, I was mentioning before, we would like to, in NGMN, to have a holistic approach. So not only from a technical perspective, a business perspective, but also to introduce society, okay, sorry if I'm not able to pronounce it, society goals and improve operational performance and see also what we can expect from this kind of technology. Also, this is not a monolithic technology, should be agile and incremental, building upon 5G. Also, because we cannot expect that every few years we change completely the infrastructure. You can imagine that the economics behind changing a full network and deploying nationwide coverage in, for example, very high frequency bands is very difficult and very challenging. Okay, I think I'm running out of time, so I would like just to present the last slide, which again, so next slide, please. Yes, thank you. Which is in line with what Alain was mentioning. Again, another player is the Horizon projects from the European Commission. So just, I think in the symposium, there were already some presentation on this aspect, but I just wanted to introduce the influence of European project, in particular the flagship European project ETSI, where university and companies, so industry are putting their heads together and trying to define again the ecosystem and the requirement for 6G. So I'm not going to spend, but I'm sure you will have the documentation, and I think a lot of stuff was already mentioned there. So I'm not going to spend much time on this slide, but just mentioning the importance of this project for Europe and a similar project all over the world. So as it was mentioned in the forum in Japan, Korea, and China, and the activities in USA and all over the world. So thank you. This is my last slide. So I would like to hand over to Joseph for the next speech. Thank you.
Thank you, Giovanni, and thanks for that great overview of that activity. I'm going to be much more limited in my scope of my comments. I'm really dealing with the IEEE standards perspective. If you can move to the next slide. Okay, I am required by IEEE when I speak about IEEE to put up this disclaimer. This is solely my views. Please do not view these as positions of IEEE or the IEEE Standards Association. Thank you. Can we go to the next slide? Okay, so the IEEE Standards Association is a fairly large standards development organization within the IEEE. It's an international standards development organization. There are over 7,000 individual members in the association and 356 corporate members in 23 countries, and many, many more standard developers participate. Approximately about 20,000 people are working under this umbrella organization that is developing standards. On the right side of your screen, you see the standardization cycle as the IEEE sees it, which is, for lack of picking a place to begin, is initiating a project, mobilizing, drafting, balloting, gaining final approval, and then maintenance, and then most of the standards we have then move into initiating the project again to update the flow of those standards as they come out of the organization. So the IEEE Standards Association view is this process and these tools and this community is empowering the world's innovators to shape and improve technology in general. So it's a continuous process moving forward. Next slide, please. Now, dropping down into one of the standards committees within the IEEE Standards Association, which is the IEEE 802 committee, which does local and metropolitan area networks. And so these groups that working groups that are part of this standards committee, most of these numbers are familiar to people doing networking, which is the 802.1, 802.3, 802.11 groups. They focus on the link level and physical layers of the network stack. The OSI stack is shown there for reference. We're only dealing with that bottom part of the stack. 6G is a much larger concept than just the data link and physical layers and its access to the media. However, those things are critical networking capabilities that are used by 3GPP. So as you can see there, the 802.1 is a higher layer LAN protocols dealing with architecture, LAN-MAN, wide-MAN interworking, and security and time-sensitive networks. Ethernet, I think everybody's fairly familiar with, and that's basically brought to you by 802.3 and the wire and fiber networks. And 802.11, which is also known throughout the industry as Wi-Fi and WiGig, is a wireless LAN networks, networking support standard. So these are all standards that have been taken up by various industry groups and have fielded significant number of products, those groups. But the standards themselves are a function of the IEEE and the Standards Association. Next slide, please. So diving down into wireless LAN, 802.11, for a couple of reasons. One, I'm most familiar with it, and two, I think it will continue to play a critical access role for 6G technologies. So the actual working group uses the SA individual process, which means that each member earns their voting rights and participate as an individual, and they're required to act as individual technical experts by the rules of the Standards Society. So this is not a standardization process. While companies do send their experts to the meetings, the technical experts themselves are supposed to be acting as individual technical experts. And that means that there are currently 444 voting members, technical experts in 802.11, and all the work is done in task groups. There are 9 of them, which I'll just go over, but all working group decisions are made by votes of these 442 voting members. So it is a deliberative and very dramatic process at times. Next slide, please. So this is the ongoing work, the standards pipeline as it is for 802.11, which is typical of the standards pipelines for basically all the other 802 working groups. There's on your left, you can see this wireless next generation group that basically is an incubator group, which then forms study groups and topic interest groups to solidify work that needs to be done. And then we move into a task group phase, of which there are currently 6 task groups that are without an approved draft, and 3 task groups that have an approved draft that is in the process. These processes are all designed to iterate the standards and move them forward and address things. This group with 6G on the horizon is probably most interested in what's going on within the 802.11 BE, which is the extremely high throughput task group. And they're currently standardizing those capabilities that will probably be germane to 6G networks. Next slide, please. Okay, so what is 6G? What is 802.11 BE going to offer 6G? It's going to offer higher throughputs up to about 30 gigabits per second, support low latency communications. It's going to be operating in the 2.4, 5, and 6 gigahertz bands, and its target completion date is second quarter of 2024. There are various use cases denoted here, which basically align with use cases that I know 6G is studying and working towards. And these technologies that are being developed, these networking technologies, will be useful for the implementation of 6G solutions. Next slide, please. Okay, so the key features that are currently being developed under BE are increased bandwidth. BE is moving to a 320 megahertz bandwidth channel. This will yield higher throughput and 2 times the ping of current existing Wi-Fi 6 type products. We're also moving to 4K QAM, 16 spatial streams with MIMO enhancements. Again, all this is improving the networking capabilities and strengthening the offering of how it can be used in 6G systems. Enhanced multi-link sharing and multi-user sharing and multi-link operations. Multi-link operations is a channel aggregation allowing multiple channels in the 2.4, 5, and 6 gigahertz bands to be aggregated together to form even larger throughputs for users. And additional scheduling techniques known as restricted target wake times are being used to address some of the improved low latency performance. And lastly, we're refining the features that were introduced in 11AX to improve overall performance. Next slide, please. Okay, in addition to that, there are other groups operating within the 11 working group that are addressing some key technologies which will play well with this 6G needs as I understand them, such as wireless LAN sensing, which is introducing sensing capability within the 802.11 specification. Randomizing and changing MAC addresses, that's addressing the way networks are managed and in the while promoting user privacy, and enhanced data privacy, which is adding additional privacy features to the 802.11 specification. Next slide, please. So some additional thoughts. WLAN is an integral part of the 5G and will play a part in 6G. The wireless LAN is pervasively deployed worldwide. There are over 4 billion current users of wireless LAN technology. The 5G architecture allows for non-3GP RAD interworking, and 6G will most likely continue to support wireless LAN interworking. And I think it is critical to promote the 6G vision that is allowed and will continue to be supported. The 802.11, to be redundant, defines access technologies in the 2.4, 5, 6, and 60 gigahertz bands. And these are essential and complementary to the 3GPP access technologies. And together, I believe they will provide a comprehensive solution space for the 6G services envisioned. And there are also several groups currently working to improve the interworking between WLAN and 3GPP 5G. And these groups, I assume, will continue their process in making that work better, and some of those ideas will migrate into 6G. Next, please. Now, there are other standards activities within the IEEE umbrella that will be enabling 6G technologies to move forward. Also, one of those is the work going on in 802.3, the Internet Task Force. And you can see those data rates are getting very, very high. They're in the hundreds of gigabits per second. These will be essential for providing the backbone to support the 6G services. Also in the wireless area, Terahertz Interest Group in 802.15 is working and working at links that have over 100 gigabits per second over the air. Also, there are many more activities, standardization activities within IEEE SA itself that are probably applicable to 3GPP activities and the 6G vision overall, one of which is the ongoing artificial intelligence standardization efforts. There are greater than 45 active groups doing this kind of work, and here are a couple of some of the standards that are being addressing the artificial intelligence world. The IEEE project P7000 series is doing a standardization process for addressing ethical concerns during system implementation, which is critical for artificial intelligence applications. The P2807 standards is a set of knowledge, addressing knowledge graphs and how those can be standardized across multiple platforms and capabilities. And lastly, as an example, the P2830 standard for technical framework and requirements for shared machine learning. So these are just a couple of the groups working on this. There are many more standards being developed by IEEE SA, which will play a role in 6G as we move forward. But I think that is my last slide. Am I correct? Yes, thank you. Handing off to Diego. Thank you for your time.
Okay, good. Well, it's good afternoon for me. Whatever it is for all of you. I'm Diego Lopez. I have been working for the last 10 years in Telefonica in research and standards related issues. And what I wanted to present today, and well, the statements I bring, or the vision I bring, is how standards are changing in these new days, as well as the requirements of the industry and the evolution of the way in which the general industry, not only in telecommunications, but in ICT in general, are evolving, and how this will affect how we think and build next generation networks. Can you move on to the next slide, please? So first of all, and this is something that in these days probably is something that is a little bit difficult to say, is that standards are extremely useful, in despite of what Dilbert thinks and what he says to the vendor. Whatever the communication, it needs to be standardized. And this is something that, if you think about the human language itself is a standard way of associating certain sounds, certain symbols with reality. In a world in which we're talking about multiple operators, multiple national environments, several vendors, and open industry, you need precisely common languages to understand one another. And this is something that is happening right now, and this is important. That is, there are strong moves through what we could call the one-headed implementations. It's a typical situation that it was not so unusual if you think about it. It's a typical situation in which you say, no, this cloud provider, this exascaler, does things this way. We have to follow them. You always have to follow them. You don't need to stand that because these guys are telling you how to do things. Again, this is not original. This is not necessarily what, it's nothing that has to do with the 21st century or the internet. This is something that happened in the past as well. And well, precisely things evolved in a certain direction in which standards and an open market were favored by several actions by the industry itself and by public powers. And this is something that is highly desirable. The same, I mean, since we are talking about communication and whatever that allows interoperability, the only way in which you can create this in an open environment is precisely by consensus. You had to make people agree. And this is something that probably is related to this perception of standards being extremely long and bureaucratic, etc., is that creating consensus and ensuring consensus and guaranteeing that consensus happens in an open environment is complicated and lengthy. Not because standards bodies are complicated or lengthy, it's because we humans tend to be complicated. Probably one of the problems is that, most of the standard bodies were created originally, and particularly in communications for sure, built by governmental bodies. They are perceived somehow as something that is related to state bureaucracy and convoluted mechanisms, but they are rapidly evolving, and they have evolving in the last times precisely into general communities, bringing together the industry, the researchers in the researchers in the academia, and for sure, the governmental authorities that have to apply that. And this is something that is going even beyond and is evolving into what we could say even a standards industry per se. Can you next slide, please? So in this world in which things have to change very, very fast, and we have to adapt, and we have to find a way in which keeping pace with technology evolution, etc., there is a set of ingredients that we need to add to the way in which we prepare standards to facilitate this, to enable this capability of influencing and favoring this open market. First is about increasing the impact, is about being able not to live on a close ecosystem of a few industries that are mandating it in some kind of oligopoly, but it's about precisely trying to incorporate as soon as possible research results, encouraging early feedback, not waiting till everything is done and complete and fully polished, and precisely by means of these actions is to foster an ecosystem that allows openly participate to implementers and adopters. We had to, I mean, the standards mechanisms has to adapt to the fast pace at which currently the industry works, and is about being much more agile and being focused on things that are not only the full, the initial informative report or the fully normative detailed documents, but precisely try to show by demonstrating that particular approaches are feasible and allowing for early access that allow people start implementing before even the standard is finished. So you can gain more insight of what is the consensus as the implementation advance. Trying to make an active coordination with the other bodies that are participating in related things. There are no, in the current standards world, you cannot say this is my stuff and I'm deciding on whatever the aspect and no one else is doing so. There are many bodies that are working in very similar directions, very similar areas with big overlaps and intersections, and it's important to facilitate formal for sure, because you had to keep the consensus and the formal processes, but as well, everything that is informal, this idea of cross-pollination, of bringing ideas from one body to another, even if not formally, facilitate the free flow of ideas. And in all these, we have a few exemplar cases that are happening right now, and I'm going to name the two I'm more familiar with, because I have been directly involved on them. With them, it's first of all are the ETSI industry specification groups, and specifically those who are related to what we call internally network transformation, precisely bringing the new ways of building networks that will have shaped the past, the 5G, not past, come on, have shaped and are shaping 5G, and will hopefully shape as well the evolution towards 6G. And a practical approach as well is in the ITF working groups, and in which, for example, this famous motto that ITF always has, and that well, is from time to time is difficult to maintain, but is important because it's a matter of the philosophy of the group, is about that everything is governed by rough consensus and running code. Can you move to the next slide, please? Precisely one of the aspects that I think is more important when it comes to adapting standards to the new times is precisely this about progressing by example, doing by example, showing what you're doing, not necessarily by preparing very well. For sure, we had to have this at the end because it's required for a formal application and enforcement of the standards, but from the beginning, precisely to facilitate that the industry moves in that direction, and that things are agile enough to keep pace with technology evolution, is precisely the idea that early in the early stages of the standards is about being able to have demonstrative deliverables that show the feasibility of what the standards bodies are doing, and allows to evaluate different choices and guide the standard production in a particular direction. Very much looking for practical results, showing which are the gaps with respect to the current technology, evaluating technology option, and deciding where to address the work of the different groups. It's important to make it lightweight. Here we don't need consensus. What we need, I mean, we need consensus in the formal standard, but what we need here is precisely openness and the demonstration that everything, I mean, the demonstration of the results and the open availability of the results. So the idea is not to impose a formal agreement or to impose that there is some kind of unanimity of any nature. Is that in the moment you gather a small group of people that are willing to do so, let's do whatever you want to do, then report the results. The result can be adopted, cannot be adopted, can be ignored, or can be assumed as that is a dead end to go, whatever. But this is about making it lightweight. Don't impose the burden of the formal consensus as well here. And for sure, as I said, making it as open as possible and facilitate something that is equally important, that is a neutral environment. It's not that everything has to do in completely open collaboration. I mean, open in the sense that is things like open source or patentless agreements, but is precisely about the standard organizations facilitating a neutral environment, very much like, for example, ETSI does with things approaches like its plug tests approaches, in which what you have is a neutral environment, an environment in which different potentially competing solutions can collaborate, can evaluate their interoperability without, I mean, with all guarantees about IPR and publicity, etc. And for sure, it's about involving the research initiatives and having, as I said, research activities being part of the standards evolution from the beginning. Next slide, please. And this is very much connected to something that, at least, I mean, it's not so, it's not the case in IT, because in IT, open source have been around for quite a while. but in telecommunications, the eclosion of open source has happened probably in the last, well, 5-8 years, in which many open source projects have started bringing solutions, complete solutions. And in some cases, some people that were involved there, or well, some observers were claiming that the open source will bring the end of standardization because it was a much faster and efficient way of producing something that it was in a that was going to allow open markets. This is something that is not exactly the same because the implementations, I mean, and it's something that is part of the decision of whoever is going for implementing a particular standards and whoever is going to, well, getting some natural or rational reward for participating in this activity and going for the implementation. And the idea is more that there is a double loop, and here you have a double loop because on the one hand we have the specification, on the other end we have the validation of the results. So there is an advantage in how standards can contribute to open implementations and providing a better understanding of the technology gaps. For sure, open implementations can provide a basic baseline or reference implementation for assessing interoperability, and this is extremely useful. And for sure, in all cases, there is a feedback from tests, for sure, to standards, and from open implementation to standards, providing early feedback and practical feedback. And what is important as well from open implementations, from the in the case of the test and validation based on standards, is precisely the assessment of the applicability of these open source solutions in the wider market. Next one, please. Just to conclude, is something that what is important is we are going for the next generation network standards. Is apart from the technical details, the technical foundations, is that we are aware that we are part of a quite rapid changing network landscape, in which we are facing next generation of networks probably at a faster pace than in the past. And in the same at the same time, there are other changes that are affecting the very foundations of what have been the basis probably of the last two network generations regarding the IP protocols, TCP, the general network stack that has become a commonplace for all solutions, precisely because these protocols that were the base of network evolution probably since the 80s are changing. There are new protocols there. There are things like pervasive encryption that are going to change very deeply the way in which network management and the access to information in the network happens. It's important, as I said, that we change the way in which we produce standards, and at the same time that we change or we adapt the way in which we incorporate these in open source implementations. We had to be more focused in the case of standards to avoid what has been called very often in the ITF as ossification, building very much detailed architecture that are extremely rigid, that don't allow innovation without departing from the standard, and being focused on aspects related to general frameworks. And the example I like best, because I was directly involved, was precisely the NFV orchestration framework. Is about being very much more focused on models and interfaces than on specific functional blocks. And with this, let me say, it's important to leave room for differentiation as the network grows and the span of the network applications extends over more and more fields. What is natural is that we are able to, we should be able to differentiate the offering and differentiate, why not, even the the kind of operator that we will be dealing with. And it's the other way around. In open source, the open source projects have tended to be in the past very much focused on, no, this is the only and one solution that is applicable. Diversity is essential. Diversity is something that should be fostered even inside a single community. And this is something that we are witnessing recently, for example, in more modern communities, like, for example, Kubernetes, in which you can choose different, you can have different choices for network plugins, for example. And again, it's about leaving room for differentiation, even while you are using open source and you are using a full set of openly available solutions. What is important is that of any nature, we had to avoid monoculture. This is something that has been, personally, I believe, has been harmful in the past, has happened in the past, and has been extremely harmful precisely for the evolution of the network technologies, and they have been overtaken somehow by other actors in the innovation space. And this is something that we have to guarantee that in the future, hopefully, will not happen as we evolve to the next generation network. And from my side, this is all. I think the next one is David. So please.
Thank you, Diego, for a very good introduction to the required evolution of the standards ecosystem or standards landscape. That's a good introduction. Hello, welcome to you all. Today it's my pleasure to provide a quick overview on how innovation and research investments may be enhanced and accelerated to market deployment through the use of global standards. Next slide, please. This doesn't look like the right set of slides, but fair enough. What has happened there? All right, I'll present this slide instead. So the slide which is missing was a quick introduction to ETSI, just reminding people that ETSI is a standards development organization with 30 years history working in the area of mobile fixed radio standards. This slide presents a simple representation of how ETSI cooperates with our 900+ members to bring their ideas, their innovative ideas, into our global standards work. The vast majority of our new and involved standards ideas come from the direct input of our members into our existing technical standards groups, technical bodies, ISGs, and others. We have today about 90 technical groups working on various technologies such as Edge, NFV, as Diego mentioned earlier, securing AI, PDL blockchain, quantum key, quantum safe, and various radio matters, just to name a few. And each of those groups have typically a dedicated work program evolution, looking at how their standards needs will evolve in the coming months and years. This can be seen as a sort of bottom-up, side-in, organic evolution of the current ETSI work program. In addition to this, we have a number of interactions with policymakers, governments, European Commission, researchers, innovators, and academics who are looking at the potential technologies that may be included in the networks of tomorrow, such as 5G evolved, and eventually 6G. To encourage this process, ETSI created a dedicated group called RISE, Research, Innovation, and Standards Ecosystem, that has the role of linking research and innovation into ETSI standards activities. This can be seen as a more top-down or side-in activity that enhances the flow of research ideas, innovation ideas through standardization and then onwards to the road of global market and global market deployments. It's this combination of bottom-up, top-down, and often side-in innovation flow that results in the richness of ETSI standards activities. Next slide, please. Okay, again, slightly different slide to the one I provided, but here we can see that it's not always easy to predict the future without the possession of a quantum-enabled AI-powered crystal ball. What we have seen here is that ETSI's created another group dedicated to looking at technology evolutions and examining their relevance to the future work programming in ETSI, and this group is called TREN. Through examining numerous technology reports and performing surveys with our ETSI members and our ETSI technical committees such as NFE, MEC, Ran and others. The trend group has identified 10 mega trends or technology trends, which you can see down on the bottom left-hand side, which are relevant for ICT in the coming years. And also, we've just published this as a white paper, 45-page white paper, which describes this in more detail. If you look at the mega trends, there's no major surprises there. Nobody's going to raise any eyebrows at 5G evolution, artificial intelligence, autonomous networks, cybersecurity, distributed ledgers, dynamic data, extended reality, IoT, quantum, autonomous systems. But what is interesting inside that white paper is the analysis, the detailed analysis of how those technologies, as they evolve, may have an impact on ETSI's future standards work. So they hold clues as to how ICT standards may need to evolve in the near future. If you wish to download that white paper, it's available off the link at the bottom of the slide. Also, we'd be very interested to have your feedback and even critique on the content of that white paper. So please don't hesitate to feedback. Next slide, please. Okay, so throughout the symposium, the 6G symposium over the past couple of days, we've heard several presentations outlining clear visions for what 6G should be, or indeed should not be. In ETSI, as part of the work of the Trend and the RISE groups, we're looking to European research initiatives to provide clues as to some of the potential technologies that may be, I stress the may be, involved in the evolution of 5G or even 6G. It's really too early to say that 6G will include this or 6G will be this, but there are several candidate technologies which are already being cited as interesting or potential enablers for future communication networks such as 6Gs. If you look to the little diagram, you can see these include things such as terahertz or sub-terahertz frequencies for both communications and sensing. Optical wireless technologies, including visible light and Li-Fi and others. The integration of AI throughout the network, all the way from the device to the radio to the edge, and even in the autonomous or zero-touch network planes. And other topics such as reconfigurable intelligent surfaces that seek to use metamaterials to enable large or passive or semi-active reflective surfaces that may be installed in buildings or in cities to further enhance the radio coverage. And these are just a few of the technologies that may require standardization in the coming 1 to 5, 6 years. And some ETSI members are already looking at opening standards groups in several of these areas. But it's always a question of getting the timing right. It's always possible to make standards too early and then they're completely irrelevant for market, or in fact making the standards too late and then the train has left and the market has moved on. So the key to standards and pre-standardization is getting the timing just right. Next slide, please. Okay, so what we can see here, if we just take as an example one of those candidate technologies, so let us say terahertz, but it could be any of those technologies. You can see that this is often cited as one of the key candidate technologies for 6G. And there are many global research and European research activities looking into terahertz problematics, challenges, and solutions. Just looking to Europe, and you can see in the slide at the center, there are a number of Horizon 2020 funded projects that have worked or are working on terahertz technologies. And there will be more projects starting under Horizon Europe this year that will further research into terahertz technologies. What we're attempting to do in ETSI is to work with our members, particularly those involved in research and also our industrial members, to identify when the time is right to start either pre-standards work or full standards work in ETSI, recognizing that the full standards work will need to be done inside 3GPP. ETSI's pre-standards work for 6G is really done in order to accelerate and enhance the pre-standards activities that will eventually be taken to 3GPP, and also solidify the input to 6G from the European research projects and investment. Next slide, please. Okay, so clearly we have to talk about 5G technologies today, because 5G is the technology that is currently being deployed across the globe. And it's important that we use caution when we use the term 6G, because we don't want to dilute the message and really make 5G rollouts questioned in multiple deployments across the globe. At this time in ETSI, we speak only of early research or pre-standards work for candidate beyond 5G, 6G technologies. But we consider that if we look at the 10-year generation cycle, because typically generations work on a 10-year cycle, now would be the right time to start examining research topics that will eventually or may eventually end up in 6G. The initial study items for 6G are not expected to be seen in 3GPP, probably SA1, until about 2026, around the release 21 timescale, or even beyond. And the possible first 6G services and deployments will probably appear around the globe in about 2030, which will be on the 3GPP release 22 or beyond. But of course, expectations often change. And as we saw with 5G, there can be a global or market call saying we need it delivered early. So we have to stay agile on that respect. As mentioned by Colin, I think it was Colin Wilcott this morning, it's essential that there is only one global 6G standard, and we all work together to avoid having a fragmentation of the standards market, because we don't want to be deploying multiple standards across the globe. And I think Europe can have a great amount of influence on the future global standards work if we approach 6G in a highly coordinated manner. Next slide, please. Okay, I'm going to quickly conclude. So to give some simple conclusions on how we may better coordinate and better collaborate and really bridge the gap between research, standardization, and eventual market deployments. I think it's really key that we accelerate the process and having early interactions between the research projects, the standardization bodies, to ensure that all parties are aware of the progress, the activities, and the priorities of each other. Also, it's important that the standards bodies, such as ETSI, simplify the message of standardization. Often standards can be seen as very complicated, very heavy, and very sort of investment unfriendly. So it's very important that we actually educate students and let's say undergraduates, postgraduates about the value of standardization and how standards can help them get their innovative research ideas out to the market. And ETSI's made a dedicated education about standards activity, 300+ page book, 100 pages of slides, which you can download and then integrate into education in universities so that people can understand how standards can help them. Also, there needs to be better understanding of the value of standardization, how providing a solution based on a global standard will in fact take that solution or that idea to a wider market. And finally, most importantly, in my opinion, is that in Europe and then globally, we need to really cooperate and coordinate between the policymakers, the research bodies, the standards organization, and industry to foster a global and open approach to 6G standardization. Next slide, please. Well, there you go. It looks like I've finished. These are just a few pointers to some of the tools that ETSI provide to researchers and innovators. We have a dedicated web page for researcher. We have a help desk where people can get information on how to get involved in standards, how to make the most of European research projects. And if you have any questions, please don't hesitate to get back to me. Thank you very much for your attention. Now I'd like to hand over to Raymond of Eurecom, who will be presenting an academic approach to 6G research, as well as some information on open source initiatives. Thank you.
Okay, thank you very much, David. I'm very happy to be here today. So my name is Raymond Knopp. I'm a professor at Eurecom, as a research institute in the south of France. And I'm actually also the president of the Open Air Interface Software Alliance, which is one of the open source projects that tries to innovate in cellular communications, both the radio access and core network technologies. So next slide, please. So, you know, as I said, I have a couple of hats here, but if I take now the hat of the academic researcher, I'd like to give a bit my view on innovating within 3GPP from an academic perspective. This is naturally a balance between long-term and short-term research. So when I would say long-term research for me is something that is quite far-reaching and risky, where you're really trying, if you're doing this in the context of working with standardization bodies or industries that are involved in standardization, you're really looking to contribute to the long-term evolution of the standard. Right? So today, this would be contributing to the core technology that will shape 6G and even beyond 6G. It's really more free research that's trying to influence the technology. And basically, from an academic perspective, this really needs vision around the requirements for future systems. And that's something, you know, a lot of people that are working in universities, they don't necessarily have, right? And that's actually where academics can learn a lot in working together with industry to understand the requirements. So basically, the technologies that are actually targeting particular applications. And then also you need knowledge on the limitations of current technology. Those are the key ingredients in order to, in my opinion, in order to create visionary research that's going to actually have an impact in standards. If we look now in the short term, here we're looking at targeted research that's within the constraints of an existing standard. Okay, so here you want to be able to contribute to well-defined areas that are identified today inside the 3GP process. So basically, you're picking study items for a particular release, and you're trying to promote ideas alongside 3GP community players. That's really the goal here. And basically, this, if you want to be successful, requires a detailed knowledge of the standard. Again, something that a lot of people in universities or research centers don't necessarily have enough of a detailed knowledge to be impactful in the short-term sense. And it also requires agility to be able to follow the 3GPP process, which is a very well oiled machine, but a very complex machine. And you basically would have to position ideas and generate ideas on the fly to be successful here. Next slide, please. But in both cases, you know, what is necessary is that you actually protect your innovations. And again, this is also something that is not natural from an academic perspective. Academics are typically, you want to produce open results as quickly as possible. That's not compatible when you want to innovate with standards. You have to also have the reflex to be able to protect your innovations and to actually be very efficient in this process here. Of course, you want to publish as usual, because that is the bread and butter of university research. And there's no reason that the academics that are working in the context of standardization should not be able to publish. On the contrary, I think it's a good way to promote your ideas in parallel to any work that you're doing in the context of standardization. And I think also, and we heard this in some of the other talks, although it was somewhat hidden, I think it's actually also extremely important to prototype as early as possible to be able to showcase innovation and understand at the same time practical consequences of the work. That is fundamental. And on top of that, for the short-term case, if you want to be successful, you have to be ready also to disseminate at 3GPP and get ready to simulate on the fly using the 3GPP methodologies. That's in my opinion, the only way you can be successful in the short-term case in a standardization context. Next slide, please. So, you know, the natural question is why would we bother with all of this as an academic researcher? And, you know, I get this question very often because now that we've started playing around in this area, you know, in my opinion, there's a lot to learn from the 3GPP ecosystem, which will allow to focus the work of a research group. I'm not saying an entire department, but I am saying maybe a couple of researchers within a department that are working more closely with industry in the context of standardization. This is a very good way to focus the work of that group and to work on problems of immediate practical value. Also, it's very valuable from the perspective of understanding the assumptions of industry. By assumptions, I mean the way things are modeled, the way systems and subsystems are simulated, and quite frankly, also the way to present results to maximize impact. There's a lot to learn from people in the 3GP process in that respect. Now, from the academics' perspective, what they can give, you know, really, we would do this to make our voices heard through direct interaction with the ecosystem. You know, in some sense, the world of academic research is somewhat unfair when you're working in an engineering field like this, because industry will always take the results of an academic community. They will filter the results and take what they need in order to push this. And the majority of academic research today is fully open and often legally unprotected. So it's ripe for the picking for companies. So, you know, if some people in the context of universities research or even state research groups, you know, if they want to get involved, it's a way of making your voice heard in what you're doing. And quite frankly, also today it is a way to tap into a significant source of funding. You know, a couple of 3GPP standard essential patents could do wonders for the budget of a research group. I mean, today, you know, if at a place like Eurecom, we spend a significant amount of our time searching for ways to fund our teams. This is just another way potentially for a research group to fund its people to generate more research results. Okay, next slide, please. So if I can just summarize here the required mindset. First is about innovation in universities. We all know how to do that. That is what we are paid every day to do. And then it's about protection. So, and here time is of the essence. People in universities will have to learn, if they want to play this game, will have to learn how to protect their intellectual property and in a timely manner. And next, please. Publish, and of course you can publish like crazy if you really want, like most of the academics do today. And finally, defend your ideas at the 3GPP. So actually get involved. And I'm happy to say that, I mean, we haven't been doing this for very long, but I am happy to say that I do see other research organizations from around the world actually getting involved and trying to promote their ideas inside the 3GPP process. And I think it's a very welcome addition, I think, in this context. Okay, the last slide, please. So I'm going to switch hats here and now talk a little bit more about open source. As I said, this was a very good way to prototype early. Where are we going today with open source and telecom? Basically, now we are looking on collaboration methodologies between the standard setting organizations and the open source communities that actually did start in the 5G era. I think there were a lot of drivers from the ITU at the beginning of 5G to come up with ways of working with open source communities. And I think you see the effect of that. Inside of 5G, we see the orchestration component, which is becoming much more important. A lot of that came out of the open source communities. Now, what can we say about this? I think personally, and this is the view also of the Open Air Interface Software Alliance, 3GPP friendly licensing is the way to go. Okay, the standard open source licensing, especially for the components of the system that are heavy in intellectual property, do not do the job. So this is a fundamental thing, and that's why we're trying to promote, at least in parts of the network, licensing that preserves the intellectual property policies of ETSI and 3GPP. We look for open source software not to replace the standard, of course not, but to drive innovation, to reduce the time between idea generation and the standardization process itself. I think open source software is a very excellent tool during the proof of concept phase of technologies and can actually accelerate injection of innovation inside the process, and perhaps even act as a feedback loop during the standardization process to re-innovate using the open source or open implementations of the type of system that's being considered. And I'm going to stop there. I hope we have enough time now for questions.
Okay, thank you, Raymond. Thank you to all the speakers for all the great insights. Indeed, we only have actually 15 minutes for the Q&A, so we lost about 10 minutes. So I'll kick it off with some of the questions. So I will first address Giovanni with a question on will 6G see new players entering the standard ecosystem, and if yes, what kind of new players, and in what SDOs? So where?
Great, thank you, Alain. Yeah, I think that I tried to introduce this topic in my presentation and also in your introduction. The point is we are seeing a lot of stuff ongoing. For example, open source was mentioned several times. And yes, we have to put together the traditional way to do standards and open source. There is also some kind of attempt to go outside the standardization bodies because they are felt, as Diego was mentioning, too slow to provide the requirements. So you want maybe to have your own solution, which of course, if you are working by yourself, you are quicker, but then you will lack the ecosystem. So again, it's important to work all together to build an ecosystem with all the aspects. So not only the run, the core, the virtualization and so on, but to put together the new frontier, which is the virtualization, the software and so on solution, which are there. But also there is an important point that we need to take into account. I think that the pandemic emergency we had is showing to us that we need to take into consideration not only the technical aspect, but also the society aspect. This is a key aspect we need to consider. We need to bridge the digital divide. We need to connect people and allow people to, let's say, survive, I would say, the emergency. This is not, okay, hopefully, this is a crisis that we are passing now, but who knows in the future what will happen. So we need to be able to take into account the input from the society. So not from the technical people, but from the society and work together there. And from that, we can build the requirement and then go back to the normal working methods and standard bodies to do our job. I hope this is sufficiently for a short time, and I would like to pass to a new question.
Excellent. Yeah, thank you, Giovanni. So we'll be seeing more of the likes of the 5G Asia and the 5G AA, hopefully in the 6G.
Yeah, sorry if I may, but not only them, by sure them, but not only them. I would say also the World Health Organization, I would say the United Nations and so on, which are not looking to to technical standard, to telco, but to how to allow people to connect and survive an emergency like we had.
Excellent. All right. Thank you so much, Giovanni. So we'll move on with a question to you, Joseph, on the IEEE. I think you alluded a bit to this interworking activities between the 3GPP and IEEE. So there are a number of activities going in there in the IEEE. So my question to you is, how do you see the interplay going forward between the 3GPP and the IEEE, especially as we see in the emerging technology trends, common technology trends of interest to both, namely the artificial intelligence, the sub-terahertz, and also the joint sensing and communication?
Well, I don't see the interplay between IEEE and 3GPP changing very much as we move forward. But I think for the most part, it is currently working very well, and those technologies are working together to provide the 5G vision. So while some people view this as a competition between two networking technologies, I really don't see it that way at all. I see it more as a mutually beneficial expansion of the networking solutions that are available to promote the 6G vision and the formation of a 6G solution. So the 802 standards in particular are simply networking enabling standards, and they work at the MAC-PHY layer. So they're not really competing with 3GPP in the sense that 3GPP is providing an overall standardization of the networking solutions that are used by their operators and customers. So part of that solution has been and will continue to be related to some of the networking solutions that 802.11, 802.1, 802.3 do provide to the world and allow those to be utilized by 3GPP and others to form the 6G infrastructure build out that needs to be done. And those standards are all constantly evolving, increasing the technologies they're using. They are embracing the trends that you mentioned of AI, ML, sub-terahertz frequencies, joint sensing and communications, and many other technologies are out there. Those IEEE standards bodies are very, very flexible and open to anyone's participation and allow for these ideas to be standardized as they are developed and brought to the IEEE standard bodies that are working on those ideas. Also, one other plug for the open source community. The IEEE SA has just recently incorporated rules of interaction for standards development for open source communities in all of the future standards bodies that are being put together, or standards groups. So there are now a set of rules that will move forward into the IEEE standards and allow for a structure for open source. It's just an additional mechanism that open source may influence the 6G standards and 6G products going forward. Thanks.
Excellent. Thank you, Joseph. So I'll move on with a question to you, Diego. So standards are essential as well as regulation, right? So would not a linear way to produce standards impact the regulatory aspects?
Well, I think it would, and I would say that this is highly desirable. I mean, regulation is an aspect that tends to be extremely slow because it's related with law making and overlike, and in some cases, in the case of the industry right now, is acting as a serious hamper for what we try to achieve. Cite the CEO of my company is like current regulation in networking is like we were regulating highways with the same rules that were used to regulating the circulation of stagecoaches in the past, well, 2 centuries ago. This is something that has to happen. Regulators have to imagine a different, more lightweight way of dealing with regulation, but for sure enforcing certain principles and applying certain principles, but probably not trying to applying verbatim all the technology details and being a little bit more agile and leaving more room for innovation, among other things, because well, and this is something that I think is a commonplace, but I think that it's worth repeating that the regulation space is not, or the regulation pressure is not equally distributed. And precisely if as we evolve into more complex, more ambitious, richer network environments, they still keep regulated as if they were the good old copper telephone lines. But the kind of applications you can apply, they become more and more deregulated. And this is at the end, is translating into something that is limiting innovation at all levels. And there's something that has to be considered. And I hope that precisely this change in the way in which standards are being built will somehow, well, inspire, or if you like, even force somehow regulation bodies to consider a different way of regulating the network space.
Yeah, excellent. Thank you, Diego. Perhaps just following on this regulatory aspect. So as you appreciate, so AI is everywhere actually in the vision to 6G. And to be able to deploy AI, we obviously need data sets, right? And proper benchmarking with the data sets. So data will have to be regulated somehow, right? When it, it's intended to be used for specification. So what are your thoughts on this? And what kind of bodies? Is it, for example, the ITU, the right body to consider for such kind of data regulation towards AI-enabled 6G?
Well, I don't think, I mean, when it comes to data and when it comes to access to data, if we're talking about personal data, I mean, the regulation of personal data goes well beyond the regulation on particular aspects. I would not rely these on a body like ITUT. On the other hand, when we're talking, and we are very, recently we have become very active in synthetic data, and the idea of using synthetic data for for training and evaluating AIs and similar elements. For this, what I believe and that will be important is the open access to this data, or at least, I mean, at least the open access to metadata that allows you to locate the appropriate data. I think for this, I don't know. I mean, I tend to be a little bit, well, I don't know if David would appreciate this, but I'm a little bit ETSI centric, and my experience is that ETSI has been extremely agile and eager to play with these matters. Is not ETSI, one of the advantages of ETSI is that it's not so much tied to government and to political arrangements and all the like. I bought support precisely looking for a more industry-based environment rather than so much governmental based. And for sure, let me say, it's about open data that is not personal, that is synthetic or generated that way, and is mostly about keeping a base of the metadata that would allow deal with the data sets.
Perfect. Thank you so much, Diego. So a question to you, David. So how can we do better actually in Europe to leverage on this fantastic research activities in our labs? And not only this, but to try actually to speed up the impact of these innovations into the market.
Yeah, thank you, Alain. It's a good question. As I tried to highlight in my concluding slides, it's all about cooperation between various bodies. So we need the buy-in and the coordinated messaging from the policymakers, from national governments, from the European Commission, from the research communities, from the SDOs, from the standards bodies, and from industry as a whole, to ensure that we bring the fantastic investments and work emerging from, let's say, European funded research, but also global research, very quickly into standards. What we saw in 5G, there was a lot of very good European funded research going on, but not a significant amount came into global standards for 5G. So I think we all agree we can do better for 6G. And a part of that is making sure that any relevant ICT research activities that may require some standardization to get to market is considered very early on in the standardization process. So really bringing these things together and accelerating it out to market, which is why ETSI is working with the European Commission, platforms such as Networld Europe, 5G-IA, and even projects such as HexaX, capturing what they believe new technologies will be in the future, where standards may be required for those technologies, and then a time plan for enabling that to get out to, let's say, the more global standards bodies such as 3GPP. Thank you.
Perfect. Thank you, David. So Raymond, last question to you. Especially with your hat as the president of OAI. So we see a number of open source projects, OAI, ORAN, ONF, Facebook Tip, and many, many others, right? So how do you see actually these open source projects impacting the 6G standardization? So with I underscore the standardization word here.
Well, let me first make some general comments without any specific example. Well, maybe one specific example. Definitely in accelerating innovation through proof of concept. I think that is definitely the case. You can, some of the examples that you mentioned, like ONF, they've been doing that for a long time. Primarily, let's say in the higher layers of the network, maybe even at the vicinity of the radio access network. And now we're also bringing it with things like open air interface and others like SRS LTE, bringing it down closer to the radio access network, in particular if the licensing is done correctly. But in the end, it's really also about how quickly these communities can put something out in comparison to commercial networks, so that it's actually useful to drive innovation. If you take open air interface, for example, we did 4G a couple of years after release 8 was already commercially available. So that was extremely late. There's not much potential for innovation. In terms of non-standalone 5G, we had it ready around the same time as commercial networks were deployed. Standalone will actually be available before commercial networks because it is already available. 6G, the questions are, can we or others in these communities put things out in parallel to early standards? So if we do things in collaboration with the standard setting organizations, then the impact is major. For sure, there could be impact in testing during the standardization process. So interfaces, for instance, that's what a community like ORAN is all about. But perhaps even collaborating with the testing activities in ETSI, open source communities can maybe play a role in there to accelerate the testing specifications. And definitely in terms of bringing smaller players into the game. That's where it can really make a difference. But the big questions really now are the actual open source methodology really within the standardization process. I think this is very difficult. And I think we have to be extremely careful with licensing because strictly speaking, open source software in the strictest sense is not compatible with a standard like 3GPP. And that's just the way it is. Huh? And some open source initiatives are not ready to compromise with patents. And this is a major blocking issue. And I think these are the things that have to be discussed when it comes to the onset of 6G.
So thank you so much, Raymond. I think our time is up. So I would like to thank all the speakers for all the excellent insights and and discussion. Apologies for the audience that we couldn't actually take your questions, but I can assure you that you can post your questions to the 6G Vote platform, and we'll be happy to take it offline and come back to you on these questions. So thank you very much, everybody, and all the best. Bye for now.